Thank you. My name is Alex Kozlov. I'm a DSP engineer at Elbit Systems, and I'm here today to talk about Elbit Systems and what we did with GNU Radio. So a little bit about me. I'm a communication systems engineer. I work at Elbit for 11 years now, ever since I've been a student. I work in the C4I and cyber division, specifically in the radio department, and my fields of expertise are DSP, modems, and machine learning, both in terms of developing algorithms and implementation. So a little bit about Elbit. We were founded in 1966. Our revenue is $5 billion. Third of it is here in the USA. We're publicly traded. We have subsidiaries all over the world. We make total of 18,000 employees. Out of that, 3,600 here in the USA. Headquarters in Israel, in Haifa. I come from Israel. And a few words about our portfolio. So we're a high technology company engaged in a wide range of programs throughout the world, primarily in the defense and homeland security arenas. We develop and supply a broad portfolio of airborne, land, and naval systems and products for defense, homeland security, and commercial applications. Our systems and products are installed on new platforms, and we also perform comprehensive platform modernization programs. In addition, we provide a range of training and support services. And additionally, I'd just like to add up that we are set up to support classified projects here in the USA. So a little bit about the division where I come from, the C4I division. Our flagship product is called E-Links. It's a family of tactical radios. We have handheld radios, man-pack radios, vehicular adapters, really the whole portfolio. We also have high-capacity line-of-sight radio links, network solution, HF beyond line-of-sight, which is close to my heart because most of my career I was developing HF modems. Soldier dismounted communication systems, airborne SDR, data links, military SATCOM, intercom and vehicular communication systems, and naval communication systems. So that's a bit about Elbit. Now, this presentation is targeting both beginners with GNU Radio and also people that are coming here to see some new modem algorithms that are being developed. And I'm going to talk about a life cycle of an idea. And I'm talking about an idea that is off-roadmap idea in a big organization like Elbit Systems. So we have a roadmap of certain products that we're developing. And for example, few engineers are having a concept which they would like to promote inside the organization. They think that, for example, a concept of a new modem. They think that this modem is gonna be good for our customers, but it's off roadmap, so it has to be done in parallel to our main work. So if we have such a concept, there is like an initial step of initial R&D phase. And after that, there is the proof of concept that we would like to present to our management. And hopefully, if they like it, we can move on with it and they can sell it on to potential customers. And there's the rest of the chain, but it's less important for this presentation. So proving your concept, what I was used to before I discovered GNU Radio. So basically simulate the idea, then I would implement it, given that the simulations were good. I would like to have some supporting features. For example, if it's a modem, I have to have a front end, I have there's the filters, there's the upsampling, downsampling, stuff like that. I'm dependent on the current state of hardware and firmware to be ready for what I would like to prove as a proof of concept. I'm depending on schedules of other engineers, and because I'm working off roadmap, and also hopefully the management gives me enough time and priority to work on my side project. Now with GNU Radio, this whole process became much shorter than I was used to. So I had to simulate the idea, it's the same thing, but after implementing the code, I could just take several EVBs of components that are in any way are going to be in our product. And by putting them together and having some already ready-to-use drivers, and these drivers, I have to say special thanks to Analog Devices for providing LibIO and stuff like that. And some ready-to-use supporting features like all the down conversion, up conversion, stuff like that, and plug and play, and I could prove my concept that easy. So a bit about what we did, what concept we wanted to prove. So there are some ways for multiple access in radio systems. There are the orthogonal multiple access methods, which are TDMA, FDMA, CDMA, all of those. And those are really the types that are currently used. And one interesting way to approach multiple access is with non-orthogonal way. So in this multiple access, we would have several transmitters transmitting to a single receiver on the same frequency at the same time, and without any PN spreading sequences. And by this, we would be able to increase our network capacity dramatically. So this is the concept that we wanted to prove. So instead of trying to accomplish this on our currently being developed hardware, I could just take few EVBs. For example, I could take the Xilinx Zinc EVB and the ADI Navasa EVB, and I could connect them with a combiner for 2 TXs, with a combiner that would be on the same frequency and at the same time being inserted into a receive channel into one of the boards. This is the setup that we used. The GNU radio was on the PC doing all the digital processing, and that way I could prove to my management that this idea could really work because I did it with the actual EVBs of the actual components that are going to be part of our next generation radio. And it was easy because, as many of you know, the integration is so simple because so much of the features are already there. All the blocks that are not highlighted are blocks that are already existent in GNU Radio. I had to implement just several blocks, which are the algorithm-specific blocks for my use case. And so what I had to do was very minimal to prove the concept to my management. And just for people here who are familiar with digital modulations, this is just the execution of what we did. So the interesting graph here is the middle one, where we can see 2 transmitters transmitting at the same time, at the same frequency. And the demodulator of the non-orthogonal multiple access is able to distinguish between the 2 transmitters, and in that way we can double the network capacity. So that's what we did with GNU Radio. And about my personal experience, getting started with GNU Radio was very, very fast because the wiki is great. And one thing I didn't know at the beginning was that there is a great chat where people always ready to help. And that's also where I got much help to make it happen. The vendors are involved. For example, we had help from Analog Devices because they already had the libio developed, so we didn't have to do that from scratch. What we would like to see in a future focus of the GNU Radio community. So currently GNU Radio is more used as a prototyping application, but would like to have it used as something that can be really embedded into products for faster SDR implementation. So more focus on FPGA accelerated blocks. There is a mention of that in the wiki, and there has been work done there, but we feel that an additional focus would be really much beneficial for us, and I think for many of the people sitting here. If the GNU Radio could be turned into a platform that's more hard real-time, more controllable and versatile, something that's more fitting to be implemented, to be embedded into a product, into an embedded product. Also, we feel that out of tree models, it's a bit complicated to integrate them, and if there was a kind of a mechanism for simplification of this, it will be very beneficial. I think not just for me, but for many that are sitting here. And also like a contribution store, maybe if you could like download from a repository different out of tree blocks that others are doing. That could be, I think, very beneficial to many users. And this is the demo. This is the set of boards that we used to simulate this idea, and it will be available later on today and tomorrow, as of tomorrow, the expo hall. And you are welcome to come and see it and let us know what you think. Thank you.